we find some lignite. That is carbon, hydrogen, and oxygen.
Can I grab? I'm just going to grab one of these lignites right here.
Bravo.
So I can show the.
There is another brown one too in there.
Yeah.
Yes. This is lignite. Lignite has a carbon between 40 and 50. Lignite. Coal in here is 70, maybe 90.
How much hydrogen and oxygen does it have?
They have hydrogen, is pretty much the same. Oxygen is more in here. It's about 28 to 30, and here is maybe 5 to 7. We're going to burn this thing, and we have more energy because of the carbon.
Coal does, yeah. That's where the energy comes from, is the release of the carbon.
Exactly from the carbon in here. And here the carbon is small. But in here you have other things. You zinc, iron, all kinds of trace elements in here. And especially if you have a lot of sulfur between 5 and 8, we call it pyrite. We're using this thing, by the way, to make sulfuric acid because we burn it because it's 7% sulfur. Sulfur here is almost 1 or 0 maybe. So we're using this lignite because the oxygen content inside, we call these functional units of lignite. How are you going to do this? This guy here. What are we going to do with that? We take this. We analyze it. And we know the functional groups. We know the carbon, 45%. We need the hydrogen, maybe 2. And we need the oxygen, 28%. We need this thing. And the other little elements. And all other trash. If we want to make carboxylic acid, we need this, this, and this. Take this thing to make carboxylic acid. Or we can make humic acid or fulvic acid. First thing we take this and we change is what we call is granulometry. We get this thing down to 200 mesh. In other words, we increase the surface area of this. If we take 1 gram, we can put it in the water, we can cover 1 square mile.
Wow.
Because this is very refined. In other words, we expose the surface area to many things on it, so we can attack it. In order to break this thing out, we change the pH. The pH in here, when we mix it with the water, is about 4 to 5. We put something with high pH that is 13, and immediately we resolve 3 things: the humic acid and the fulvic acid, and the other garbage at the bottom we call it humine. You can use it in the soil because there is a lot of stuff in here, silicon and others. But in here though, this is what you have: humic and fulvic acid. They are both soluble and high pH. pH 10, you have soluble, the humic acid and the fulvic acid. Now I want to separate them. In other words, I want to bring it down here. We took this thing out, the humine. And now in here I have humic and fulvic acid. humic acid or fulvic acid. I changed the pH to this, way down to about 3. Now you separate humic and fulvic acid. The humic acid sits at the bottom, and the fulvic acid stays in solution. Are you familiar? Now you understand that thing, right? So you can extract humic and fulvic acid from many things, providing you have the right carbon inside, the right hydrogen, oxygen. And look at the ratio. 40, 1, 20. Carbon, hydrogen is 40. The hydrogen. In other words, you have, for every molecule of hydrogen, you have 40 molecules of oxygen. You need this thing because you're going to balance it somehow. So, whatever is down here at the bottom, if you compare both, remember where the book, we have a book inside to see it, you know. What would I do with these little guys? Well, they're inside the soil already. These things do a lot of work for us. They chelate or they complex other elements which the plant can pick it up. But mostly, it's a food for the microbes. This, you have to have it in your mind without even looking at the books. So, the difference between lignite and coal is the carbon, and also the oxygen. The carbon here on this thing is 80%, hydrogen maybe is 1, and the oxygen maybe 5. In this guy is 40, 2, 20 atlases. We call this functional groups. Fulvic acid is fantastic, by the way. It's a miracle thing. People begin to know now. Chinese have been doing this for 10 years. We have a plant in China that has a lot of this. If you have strata in the soil and you have a lot of pressure in here, a lot of temperature, it goes down a bit, and here it becomes coal. And what about if it's carbon 100%? What is it?
Diamond?
You said it. I said it the other day. This is diamond here. That's why you find very little, you know, we'll dig that, find this thing on it. So, in here, this is peat. This is cheap lignite, and this lignite. They call it leonardite in here. This is what we take to extract our humic and fulvic acid.